Can light turn into a particle? In the energy filament theory, the answer is yes. As we've discussed before, light is not a small ball, but rather a fine, short filament twisted like a helix, pushed forward layer by layer through the energy sea. In Season 2, we also explained that an electron, as a particle, is essentially a closed-loop filament with circulating energy inside and coherence window patterns on the outside. So, in the energy filament theory, the relationship between light and particles can be summed up in one sentence. A light filament is an unconnected loop, while a particle is a connected loop. When the environment is extreme enough, the two ends of the twisted light filament might meet and lock together. From that moment, the energy sea no longer pushes it forward, but instead, it circulates along the closed loop. The same filament, which was previously propagating forward, now becomes a localized circulating filament. This is one way an electron is born when the light filament locks into a particle loop. How often does this happen in reality? As discussed in Season 2, with the probability of 1 in 1062, out of countless attempts to form particles. Even a single success can create the entire universe over time. Using the same probability of 1 in 1062, we can estimate how often sunlight turns into particles. The sun emits an astronomical amount of light filaments per second. But with this probability, we find that it would take, on average, about 3 billion years for a single light filament to successfully form a particle loop. This means that in the gentle environment of sunlight, light turning into a particle is almost a never-happening event in terms of probability. Only in extreme fields, such as in high-field quantum electrodynamics QT experiments or in the intense curvature near black holes, do light filaments have a real chance to be forced to meet at their ends and form a stable particle loop. Thus, in the energy filament theory, light can turn into a particle. But it's not something that happens casually. It's a locking mechanism that the universe occasionally activates under extreme conditions. Most of the light we see in everyday life is destined to remain just a passing filament, never being sealed into a particle. For more insights, check out the next episode, Why Doesn't Light Leave Static Footprints? Follow and share to spread these new ideas in physics and help us all gain a clearer view of the universe.